Hello everyone, myself Sai Krishna. Today I am here to present you about Reynold and Mason's charge formation theory of hybrid engineering. So these are the contents I am going to present. Those are Wilson's theory of charge separation, Simpson's theory, as well as Reynolds and Mason's theory. So firstly, how we see about the charge formation in clouds. So during the thunderstorms and lightning of various climate conditions, we have positive and negative charges that become separated by the heavy air currents with ice crystals in the upper part as well as rain in the lower parts of the cloud. This charge separation depends upon the height of the clouds, which range from 0.2 to 10 kilometers. With their charge centers at the distance of about 0.25 to 2 kilometers. The charge inside the cloud may be as high as 1 to 100. Clouds may have a potential as of 10 to the power of 7 to 10 to the power of 8 with field gradients ranging from 100 volt per centimeter to 100 kilovolt per centimeter. The energies associated with the cloud discharges may be very high. So the upper regions of the cloud, which are of a cloud, are positively charged, and lower region are negatively charged. As you can see in the figure, here we can see the cloud motion, and the upper one of cloud is of positively charged, as well as lower one is negatively charged, and the local region near the base, that is this head positively charged. Here you can see, and this is the ground, and this is a field gradient from the ground. So Wilson's theory. So basically, the theories are assumptions that are because on the basis of some criteria, the Wilson's theory proposes that a large number of ions are present in the atmosphere. Many of these ions attach themselves to small dust particles and water particles. A normal electric field exists in the atmosphere under fair weather conditions, which is generally directed downwards towards the head. The intensity of the field is approximately 1 volt per centimeter at the surface of the earth and decreases gradually with the height of at 9,500 meters to it is like 0.02 volt per centimeter. A relatively large raindrop. So let's consider a raindrop of 0.1 centimeter radius falling from the field becomes polarized. The upper side acquires a negative charge as well as lower side acquires a positive charge. So based on the Wilson's theory, in the lower part of the drop, the raindrop that attracts the negative charges from the atmosphere. Thus, both positive and negative charges were mixed up and now separated. Here you can see the water drop, and here you can see the negative charges as well as positive charges, and you can find the negative ion here. So Simpson's theory. So this deals with the three essential regions, that is A, B, C. When we separate a cloud or a raindrop into three regions, and here the below region of A, that is the air currents travel above 800 centimeters per second, and no raindrops fall through. So in this region of A of a cloud, the air current travel about 800 centimeters per second, such that there will be no raindrop that will be falling from the cloud. So in this region A, the air velocity is so high that is enough to break the falling drops, causing positive charge spray in the cloud and negative charge in the air. The spray is blown upwards as the velocity decreases. The positively charged water drops recombine with the larger drops and fall again. So thus this positively charged, as the velocity decreases, the raindrops will again become the larger drops and have a moment fall again to downward there. So thus this region A becoming very positively charged, and the region B becomes negatively charged by the air currents or the airflow. The upper region of the cloud, the temperature is very low, and only ice crystals exist in the upper or the topmost region of the cloud. So here you can see the impact of air on the crystals make them negatively charged. Thus the distribution of charge within the cloud is as shown. So here you can see the cloud. When we consider this is the cloud motion that is moving this side. So the air currents you can see as the arrow marks. So these air currents which are traveling for 800 centimeter per second approximately have a disturbance in the distribution of charges, where the positively positively charged particles are up or on the top side of the cloud, as well as negatively charged particles at the bottom of the cloud. And you can see the negative rain as well as positive rain here. And since the ice crystals are formed, means there is less temperature on topmost of the cloud. The temperature ranging from -10 degrees, -20 degrees, etc. So, what is Reynold and Mason's theory? So, according to this theory, the thunder clouds, when happening in the climatic changes or heavy rains, the thunder clouds are developed at heights of 1 to 2 kilometers above the ground level, and they go up to 14 kilometers. So, the temperature is 0 degrees Celsius at 4 kilometers and may reach up to -50 degrees Celsius at 12 kilometers. So, on going up, the temperature slowly decreases and they go into a -degree centigrade. So the water droplets do not freeze at 0 degrees Celsius and freeze only when the temperature is below -40 degrees Celsius. Here we are talking about the water droplets that are in the cloud. So these form solid particles of which crystalline ice patterns develop and grow. So thus the thundercloud consisting supercooled water droplets moving upwards and large hailstones moving downwards. The ice sprinklers should carry only positive charge upwards. So the water has H plus as well as OH minus ions. The ions density depends upon the nature. So the lower part has a net negative charge density OH minus, and upper portion has a net positive charge density that is H plus. So this is proposed theory of Reynold and Mason. So according to Mason, the ice splinters should carry only positive charge upwards. The water, being ionic in nature, has concentration of H plus as well as OH minus ions. So the ion density depends upon the temperature. Thus, in an ice slab with upper and lower surfaces at the temperature, like when we consider T1 and T2, and T1 is less than T2, there will be a higher concentration of ions in the lower region of the cloud. So, however, since H plus ions are much lighter, they diffuse much faster all over the volume. Therefore, the lower portion, which is warmer, will have a net negative charge density, and hence the upper portion, that is cooler region, will have net positive charge density, that is of a ice particle region. Hence, it must be appreciated that the outer shells of the frozen water droplets coming in contact with the hailstones will be relatively cooler than the inner core warmer water. So, and therefore they acquire a net positive charge. So, when the shell splinters, the charge carried by them in the upward direction is positive. So, according to Reynolds' theory, which is based on experimental results, the hail packets get negatively charged when impinged upon warmer ice crystals. So, when the temperature conditions are reversed, the charging polarity reverses. This is the proposed theory of Reynolds. However, the extent of charging and consequently the rate of charge generation was found to disagree with the practical observations relating to thunderclouds. This type of phenomenon also occurs in thunderclouds. And here is the equation or the derivation of rate of charging of thundercloud. So the experimental results or the theory proposed by Mason and Reynolds. The Mason considered thunderclouds to consist of a uniform mixture of positive as well as negative charges. So a cloud consists of both positive as well as negative charges. Due to hailstones or air currents which are very high at the upwards, these charged particles, the charges are separated vertically. So if consider a lambda, a factor which depends upon the conductivity of a medium, then there will be a resistive leakage of charge from the electric field buildup, and this should be taken into account from cloud charging. So let us consider E as an electric field intensity and V be the velocity that of separation of charges due to air currents, and rho is the charge density of the cloud. Then the electric field intensity E is given as d by dt plus lambda E equals to rho v. That is when we uh, consider only for equation E in the 8.2, it will be like rho v by lambda, that is equals into 1 minus exponential of minus lambda t. So this equation assumes E equals to 0 and T equals to 0. It is the assumption that the start of the charge separation. That is, there is no separation initially. Let Q be the separated charge and Qs be the generated charge. Then here rho equals to Qg by AH and T to Qs by A, A epsilon naught. This is the dielectric medium. So here we know that epsilon naught is the permittivity of a medium, and A is the cloud area, and H is the height of the charge region. So upon substitution of equation 8.2, that is this equation, we get like in the equation of E, we get Qg, that is from 8.3, we get Qs H by V by 1 minus exponential of minus lambda t, that equals to m by v into 1 minus exponential of minus lambda t. So where m equals to Qs, H equals to the electric moment of the thunderstorm. The average values observed of the thunderclouds are, see, suppose the time constant 1 by lambda equals 20 seconds, electric movement is 110, and the time for first lightning flash appear be t equals to 20 seconds. These are the assumptions that we have to have an average value. And the velocity of separation of charges will be like 10 to 20 meter per second. So substituting all these values, we get Qg equals to 20 meter per second. So these calculations using Mason's theory show the maximum charge transfer, that is up to 3 into 10 to the power of 3 Tesla ESU per centimeter square of contact surface for a contact period of 0.01 seconds. The transfer is in a 0.01 second, the maximum transfer is 3 into 10 to the power of 3, where T is the temperature difference. This theory and observations of Reynold gave values of 5 into 10 to the power of minus 9 ESU per crystal impact of a temperature difference of 5 degrees Celsius. Mason's theory seems to give much higher values, and yet it has to have an explain of a phenomenon as well. So in this way, these are the theories that give us the high voltages and the maximum air transfers or charge transfers that occur in the clouds during the thunderstorms and lightning. Thank you.